manufacturing process. This is Professor N. Venkatachalapathi, Institute of Aeronautical Engineering. I would like to discuss about welding and its types. Before going to discuss about the welding process, first let us see what is the history of welding. So during Second World War, there is a lot of destruction has been occurred in Japan, that Hiroshima, Nagasaki, and so many problems may arise due a lot of problem in construction, and so many damages will occur. At the time they have introduced the term welding, and as per this history is concerned, in 1880 Auguste de Meritens, working in a Clairvaux laboratory in France, used in the heat of an arc of joining lead plates for storage batteries in the year 1881. It was his pupil, a Russian Nikolai Yan Bernardos, working in the French laboratory, who was granted a patent for welding. So, in general, the term welding can be defined as it is the process of joining two similar metals or dissimilar metals by adding filler metal, without adding filler metal, by application of heat and pressure, without application of heat and pressure. This is a basic definition of welding. So it is not just has arisen this process, it is a traditionally during the World War Second World itself, it has been introduced to the history of welding. As you know that from that day onwards, today there is a lot of changes in the structure of welding process. So many classification of welding also has been existed, and still the research is going on this welding process also. Now let us see, as per the manufacturing process is concerned, we have discussed the metal casting process in the previous first unit, and in this second unit it is a welding and its types and some of the important welding process to be discussed in this course second unit. So whatever I wanted to discuss in this secondary welding process, why it is called secondary? As you know that the primary welding process is nothing but metal casting process, because there directly the component will be obtained at the original. But whereas in the case of welding process, or you can also call it as a fabrication process. So fabrication means once you have made a component, if any damage, any joining of one or two parts, there you can introduce the secondary process is called welding or fabrication process. That is why, being a mechanical engineering student, he or she should be able to understand the process which incurred in the secondary process, where you can perform the fabrication process, welding process, and what are the precautionary steps to be taken, and what are the metals to be used, what type of welding it is. Everything you should be able to understand clearly during this manufacturing process, the welding, and how we can able to define the welding process, and what are the major important information required for this welding process. As I said that the term welding can be defined as it is the process of joining two similar metals or dissimilar metals by adding filler metal, without adding filler metal, with application of pressure and heat, without application of pressure and heat. These 6 terms plays an important role for defining the term welding process. As you know that here another important point is heating. Heating is generated through various sources. So for example, either it is an electric arc or gas flame or laser, some electron beams, some friction, and some resistance and ultrasound. Based on the heating can be generated. The name we can also call it as a gas welding, arc welding, laser welding, electron beam welding, friction welding, resistance welding, ultrasound welding. All these names has been termed as according to the what type of heat can be generated with the various sources. And another important thing, apart from the material to be welded, one important thing is that filler material. Filler material is very important, where you can use the welding process or fabrication process. the filler to be added to have a good strength welded joint. Okay, some cases without filler also can be used for joining to similar metals, say some friction welding also. Okay, and another important definition for the welding, it is used to produce a permanent joint rather than bolting and riveting. So as you know that welding is a permanent joint, whereas riveting means it is a temporary joint while you can use it and you can dismantle it. But where in the case of weld, once you have to join, once you have to perform the fabrication process, it cannot retract. It cannot be redo. So that is why it is a permanent joint. So especially wherever you can really use it, our conventional applications, we can most widely use it the welding or secondary process. And I have referred a lot of literatures where is another type of welding is soldering and brazing. So this is also comes under the welding process, but where it is a different from the temperatures. The soldering, the term soldering can be defined as it is the process of heating the metals below 420 degrees centigrade, we can call it as a soldering process. Above 427 degrees centigrade, we can call it as a brazing process. These two processes can be discussed in detail in the further classes also. Okay, I hope all the students and the important know about the welding and its definition. Now let us discuss about what the types of welding process, how we can able to explain with the diagrammatic representation of arc welding, gas welding, TIG welding, MIG welding, etc. Now step by step procedure you can able to do. Now before going to discuss all the welding process, let us see recap of this. Welding, it is a fabrication technique, and here heating is generated through various sources like electric or gas, laser, beam, and resistance and ultrasound, etc. And apart from the materials to be welded, we have to use filler metal to become a strength. In some cases, some metals to be joined with the adding of filler. Some metal without filler also you can able to have that joint. And another important thing is welding is used to produce a permanent joint. Absolutely, this process can be done with a strong and permanent joint, where it is not like the riveting and bolting. It is not a permanent joint. Wherever you can fix it, we can use some rivets and bolts, etc. When you wanted to remove that, we can use that. But where in the case of welding is a permanent joint, and also it is a secondary process. And last but not least, certain literature refers to soldering and brazing also comes under the subdivision of welding process. Why? Because especially majority of electronic components, some IoT sensors and all, we can join with the soldered iron. So where we can able to join with the thin shapes, thin type of articles. Okay. So this is what about the welding and its definition. Now let us see the types of welding process. So as far the welding is concerned, already have discussed about the definition of the welding. And traditionally during the World War II itself, it has been started, and still it has been done lot of research on doing the various types of welding process. Still another advanced welding process also has been introduced, like laser beam welding, electron beam welding, ultrasound welding. Okay, at foremost some advanced welding process also has been existed, so that the strength and some material to be sound can be reduced, and some precautionary elements also will be taken into the consideration. All these things, still the advanced welding also going to become in future also, because it is a must for joining a two piece of materials either similar or dissimilar with the permanent joint. Okay, now let us see the classification of welding process. Majorly, in general, the welding can be classified into three major types: solid, liquid, and gases. These three types. Accordingly, again, you can subdivide it into this classification of welding, the first and foremost thing is arc welding process. In arc welding process, again it can be subdivided into shield metal arc welding, gas metal arc welding, and gas tungsten arc welding. So this is why arc welding, it is a traditional process. Wherever you go, small workshops also they can be introduced this arc welding process. Even an engineering student able to go and visit that workshop, how they'll performing arc welding, what are the setup it is there, how they can able to connect workpiece, electrode, and what is the base, and what type of power source can be used, DC or AC or strike polarity or reverse polarity. All these things to be considered in the arc welding. In detail, we will study the step-by-step procedure. Now, second important thing is gas welding. So, especially when you speak about gas welding process, means it is a oxyacetylene welding. Oxyacetylene. So there is a combination of oxygen and acetylene with the composition. If it is a composition will be equal, we can call it as a neutralized flame will introduced. If the excess of oxygen, we can call it as an oxidizing flame will introduced. If the excess of acetylene means that is what carburizing flame will be introduced. All the three flames will be come through that tip of that gas welded equipment. So based on that only, here the temperature is also a little bit more in this gas welding, and where some type of metals cannot cut, again you can use the gas cutting process, where we should able to have more focused heating in a particular part. So this also we'll discuss in detail in the coming classes. And next, third important thing is resistance welding. So basically the term resistant welding can be defined as, it can be majorly depend upon heat generated I square RT. So heat generated, which is equal to I square RT, that is current square, resistance, and time. So these three parameters are very, very important for the resistance welding. So totally the resistance welding will depend on this generating equation for I square RT. And again it can be subdivided into, there is another 6 different type of resistance welding process. The first and foremost thing is the spot welding, seam welding, and percussion welding, projection welding, and butt welding. All these type of welding comes under the resistance welding. Mainly the principle involved in this I square RT. And coming to the next classification of welding is energy beam welding. So the beam, it is a little bit advanced type of welding, where the electric beam is introduced to joining of two similar and dissimilar metals. Even laser beam welding. Now look at all so some medical applications and all, you can use the laser beam for joining. Even if your leg or hand will be broken, the laser treatment can be introduced to fit in a effective manner. So this is what about the principle behind the energy beam, where we can call it as electron beam welding, and another type is laser beam welding. And another type of classification is solid state welding. So solid state welding, again it can be defined into classified into two types: ultrasonic welding process and friction welding process. Ultrasonic means due to ultrasound, 20,000 hertz, the frequency has been introduced in this ultrasonic welding. So there you can able to join the two metals or the similar metal. And friction, the two rods will be rotated, and putting due to friction also the two men join. Two metal pieces also can be joined easily. There is no filler metal can be introduced in the friction welding. Only rotation and force to have joining of the two metals. So this is what the classification of welding process. First one, arc welding process, and second one, gas welding process. Third one, resistance welding process. Fourth one, energy beam welding, and last but not least, the solid state welding process. So still the lot of classification also has been introduced in majority of industries where you can perform some construction industries, some machineries. There you can perform all the advanced welding process also. So that is why the how they can able to perform the welding. After that, they can able to do the structure of that weld beam mandal, etc. That can be derived, and they can able to use for the different set of application. Now let us discuss about one by one welding process. Now, what is arc welding process? So when you speak about welding process, means even a layman can understand arc welding process. In everywhere, wherever you go, either it may be village or city, one small shop which is having some arc welding setup should be based in that. In the arc welding setup, there will be workpiece and that electrode gun, and that will be connected either single phase or three phase. There will be generator, and how they can made it with the positive, neutral, and negative, and how they may join the welding in a proper heating process. Okay, so let us see, the term arc welding process can be defined as whenever the welding power is applied is used to create an arc. So there is a spark between the base metals so that it can be welded. So an electrode to be used, some electrode rod they can introduce to joining the filling of that gap. Okay, so again the arc welding process, the heat is generated in the base metals which will cause to melt and fuse together. So to reach that particular temperature, so that once it has been heated, and there will be introducing of the arc with the help of the electrode, it can be joined with the given some time, some fraction of time. So the electrode may be either consumable electrode or sometimes non-consumable electrode. So this is also depending upon the classification of consumable, non-consumable. Wherever the TIG welding can be used for non-consumable electrode, and MIG welding is consumable electrode to be used. In that classification, we will discuss in detail about the TIG welding and MIG welding. And coming to this, that heating, then filler material. So filler material may be added to enhance the weld quality. So weld quality to protect the welding area, so that it's free from the external contamination. So even once you have to perform the welding process, immediately by using chipping, we have to remove that extra material, some red-hatted, the chipping chips can be eliminated by using the chip. So immediately after performing, with the help of the gloves and all, you can remove that, so that the quality may be improved. Otherwise, it is very difficult to remove that extra contamination part also. So that is why the arc welding process, majorly there will be a power supply and a filler metal to be used, and there will be a DC, SP or DC, RP or some AC, which type of power can be used, we will discuss in detail. Okay, now coming to this arc welding process, majorly it again can be classified into three types: SMAW, GMAW, GTAW. So what first thing is SMAW, means shielded metal arc welding, where that arc should be in a shield form, that we'll see in diagrammatically. And the second one is GMAW, means gas metal arc welding. So we're performing the arc welding, some gas, okay, how they can flame will be introduced and tungsten arc welding. This also, that is what tungsten inert gas arc welding, and metal inert gas arc welding. So these also comes under arc welding only, where we can use it for that is what tungsten means, you can use the non-consumable electrode, and metal arc means consumable electrode to be used. That is the only difference between the metal arc and tungsten. TIG welding, MIG welding, we will discuss in detail. So this is what about the arc welding process. Now let us see, I will discuss in detail about the this SMAW. The diagram can be illustrated in detail, and let us see what are the basic principle involved in the shielded metal arc welding, SMAW. So especially from the diagram we can see there is a base. Above the base there will be, and we should keep the workpiece, and top of that electrode, and inside there will be cone, and how we can able to interact this shielded this shape only, we'll call it as some shielding shape, okay, so that it may cover the uniform flow of the metal. That electrode metal will be filled in this gap, either it may be V shape or U shape or J shape, whatever the shape you can able to prepare, that you can fill by fixing of the two metals. So this is what very important concept in shielded metal arc welding. So in this process mainly it uses a consumable electrode. Yes or no? So in this process we can use the consumable electrode. So there will be electrode, it can be, it is in a wire form or a continuous wire form, where you can able to use as a filler material, okay. So once the electrode is covered with a flex, and that gives off vapors to shield that welding area. So it is a one important point. So the electrode is covered with a flex that gives off vapors to shield. So how the shield may generated due to that flex in that welding area, and the core of the electrode melts into the welding area and provides necessary filler materials, and they may fill and put it, and joining can be occur. It will become good strength. And another thing is SMAW, that is shielded metal arc welding, is most commonly used, and also it is very easiest to employ welding process, and which is suitable for mainly for ferrous materials. So all ferrous materials can be either mild steels, okay, steel, or ferrous metals can be cast iron. This type of metals and all can be, obviously you can use this shielded metal arc welding process, okay. And welding electrodes, now let us discuss about that. Welding electrodes are comprised of material with the compatible with the materials being welded. So whatever this ferrous material, what related to that, there will be a coated electrode should be used, so that the joining will be performed effectively. So look at this illustrated diagram for shielded metal arc welding. So we can clearly understand that. So how there will be workpiece and the electrode, and how they may join, and where the electrode should be kept. With this we can see power source, there will be power source, and there will be one ground neutral. You can make it some ground, and one electrode can be kept, electrode torch, and there will be workpiece. So in this only workpiece and electrode in between, this only. Here not able to understand, this will be magnified the diagram. You can able to see the shielded, there will be a core, from the core how the fluid flow will be occur, and with the surrounded by the some shielded arcs, okay. So this is what about and we can call the weld bead. So whatever the shape we can able to get, that is called weld bead. For example, you can see in this, and here this is called weld bead. So it is a front view. When you wanted to see in the three-dimensional figure, and when you start the electrode here, it is continuously moving this. So what are the shape, either V or U type of welding can be obtained in the shielded metal arc welding process. So this is what about the shielded metal arc welding process, where you can able to perform the electrode and the electrode holder and workpiece and how the power source will be positive negative will be connected, and this is what about well performing the shielded metal. Now coming to the gas metal arc welding. So this is a similar to that shielded metal arc welding, only the difference is in a gas metal arc welding process. It is a fed a wire continuously serves to both electrode and as well as filler material. So here also the shielded gas is flowed around the wire. Shielded gas which is flowed around the wire to protect from the weld site contamination. So here there is a contamination occur while performing the joining process. So to eliminate that, you can able to use that expert, that skilled labor to be used to performing this welding process. And it is also shield metal arc. It is a different from the gas metal arc welding and shield metal arcing. Let us say it is a totally unlike from SM shielded metal arc welding. Why? Because in this process it is a very fast compared to that. So the shield is very slow process. This is very faster. Why? Because the electrode fed continuously. So in shielded only one rod will be taken until completion of that. Again we will take one more rod. So but in gas metal arc welding there is a filler. It is a continuously some rope form. So whenever we can kept that wire, it is continuously moving, so that it is a very faster process. Okay, so whatever the welding area should not disturb. So in that electrode can be used after completion of the electrode, there will be break occur. Again, if you take that fraction of time, also it leads to be some damage in that surfaces also will be done. So and one more thing, no time is wasted replacing the consumable electrode. Where in the case of shielded metal arc welding, there is a wastage of time by exchanging the electrode. Here, there is no such wasted in replacing the consumable electrode. Okay, and another thing is, though gas metal arc welding is a very fast, so that the supply of shield gas and continuous feeding of the wire requires a bulky mechanism. The mechanism should be little bit complex. Okay, so this reduces the ease of use. So whenever that complicated mechanism reduces the easy of use and all. So wherever certain complex shape complex continuously can perform that type of things, only you can use the GMAW. So this also can be referred to as metal inert gas welding. Metal inert gas welding. This is what the difference between a shielded metal arc welding, gas metal arc welding, where gas metal arc welding is a very faster compared to shielded. So because there only electrodes difficult to change, but here there is no changing of the electrode. It is a continuous electrodes to be used. It is in a thin wire form, so that there is no wasting in the time for replacing the consuming of the electrodes. Here the consumable electrodes to be can be used. So this is what about the gas metal arc welding. Look at how this gas metal arc welding can be explained diagrammatically. So even in the examination point of view or competitive examinations also, this diagram will understand clearly what are the various parameters, what are the nomenclature while performing this gas metal arc welding process. So the first and foremost thing is, we can see the first there will be a base metal. This is called base metal. So wherever you can use the base metal, then second, so this the blue in color is a solidified weld metal. So we can start welding from the starting to here. Automatically heat can be occur, it will be transformed easily, so that it is already solidified weld metal, and there will be arc can be generated through this torch. So look at how the solid wire electrode can be introduced. That red color, it is continuously coming, so that there is no wastage of time giving that all electrode and all. And here there are two wires, one is the current conductor and the other one is the shielding gas can be occur. And the central rod, red in color, is the solid wire electrode, where this red color only electrode, that only consuming the filler and to joining of the this metal. Okay, and here the shielding, you can see shielding can be occur at the around, and whenever the arc can be introduced, some flower shaped shielding can be introduced. Okay, and whenever the wire guide and contact when it touches, again there is a solid wire can be introduced once again. So this is what how the gas metal arc welding can be performed. Here the travel left to right. So that is what again when different types of welding process also is there. Left to right technique, right to left technique, and incline technique and all also. So depending upon our application and usage only, you can able to use the different type of welding travels. Okay, so this is what about the gas metal arc welding process. Now look at, so in this gas tungsten arc welding, so this is what another important classification of the arc welding process. Here tungsten, whenever the TIG welding, tungsten inert gas welding, we can use the non-consumable electrode. Obviously, when the tungsten inert gas welding, obviously non-consumable electrode to be used. Okay, whereas shielding gas and filler metal are fed separately into the weld along the side to electrode. Okay, so like that, if this is the workpiece, we can keep like this electrode holder. So whenever performing the welding, we can to the left to right or right to left, depending upon the our application or technique of the filling of that filler metal. Okay, and GTAW, which is also characterized by very high and uniform weld quality. In this also can have some good quality depending upon the operator, skilled operator is there, automatically the high quality can be produced. Even suppose the students are suffering while performing in a welding in that manufacturing lab, they're difficult to perform welding, so they have some fear. So whenever you are performing this welding process, you should do some precautionary measures. So that is goggles, and you should wear the gloves and shoes, and you can put apron. All those things very must. Even small fracture of some flames will fed into eyes. Also, it is very dangerous for human hand. So that is why a lot of care to be taken while performing this type of welding process. That's why you should some expert operator. You need some skilled operator. Even a new fellow will can do, means it is very dangerous to operate. First he has to observe how he will performing. So after that only he can slowly can operate one by one. Then he will become a skilled operator. And one more thing is this GTAW can most widely used for thin sections of stainless steel and light metals. This is the another important. All stainless steel, light metals, you can perform this gas tungsten arc welding process. And this also we can call it, as I told, that tungsten inert gas welding. So it is one of the most important welding process. Even for the examination point of view, also they can ask a lot of questions about tungsten TIG welding, MIG welding. So when you speak about TIG welding, there is a non-consumable electrode to be used. When you wanted to use the MIG welding, consumable electrode to be used. Okay, and also here the very thin sections can be performed here, especially for non-ferrous metals like the stainless steel. Some light metals also can be performed easily in the gas tungsten arc welding process. Okay, now let us see this how we can able to illustrate it with the diagrammatic and the real life application. So look at in the left one, you can clearly understand that there will be workpiece. Okay, so we can see there are two workpiece. This is workpiece 1 and this is workpiece 2. Okay, and there will be a weld torch. In that electrode rod can be introduced, non-consumable electrode to be introduced. This is the welding torch. We can call it as welding torch. And this is a molten pool. So while touching this this thing and electrode, so here this is a filler rod. We can also provide filler rod. So filler rod and welding torch will be kept to 45 or less than or greater than, depending upon the inclination required. A better quality of the weld to be performed, you can able to put the angle should be either 40 to 60, 50 to 70, depending upon the quality of the weld bead. So that is very important. So obviously you can see the workpiece will be kept positive, and this electrode will be kept negative. So always you can join the power connections. Always workpiece will be joined in the positive, and this electrode will be kept negative. This is negative connection. This is positive connection. Okay, so that you can able to perform that. Electrode and filler rod will be kept at the inclination of 40 to 60 degrees, 40 to 60 degrees, based on our quality of that weld and also. Okay, so and shielded gas also, you can see how it can able to cover, like in this right side in the live, how the skilled operator is performing. You can see this is electrode, yes or no? So this is electrode, this is the torch, and how they can able to introduce this workpiece, and he's wearing the goggles and gloves and apron. So these are must while performing. So because without adding this shielded gun also, definitely it faces some difficulty in your eyes also. Eye will be affected with the high rays will be introduced while performing the joining process. So this is what TIG welding process, and a manual representation. This is three-dimensional real performing the TIG welding process, a highly skilled person. So this is what so a new student or operator, it is difficult to perform. So that is why a little bit experience is required while performing this type of welding process. Okay, so this is what about the TIG welding process. Now coming to this defects. So in any process there will be some defects. Even the casting process also, we have discussed some of the casting defects like blowholes, sand drop and shrinkage, etc. And in this welding process also, there are series of defects may be introduced. So the majorly we can call it as lack of fusion. There will be some cracking and some excess penetration and porosity and inclusions. So wherever what are the defects, the one thing you need to understand. So that is what we can call it as a cause and effect diagram or Ishikawa diagram. So for example, so this weld defect is lack of fusion. Lack of fusion. So in this, what are the various causes to occur lack of fusion, and how to eliminate this causes, what are the effects to be taken. For example, lack of fusion which arises due to little heat input. So little heat input or too rapid motion of the welding electrode. So that is a person, a little heat input is very less. Little heat input and too rapid motion. Too rapid motion, that is there is a disturbance between the electrode and torch, should not have some movement. Motion should be very transparent. Once you have to fix it, the electrode and electrode torch uniformly, it will flow exactly same type of speed. Even the speed increases, there is a problem. There is a speed decreases, there is a problem in the joining of the two welding process. That is why when you wanted to improve this lack of fusion, obviously we should maintain the appropriate heat input. What are the requirement of the heat treatment? So this can be do it properly. And similarly, too rapid, so rapid motion to be eliminated. So uniform motion should be done. So the speed of the motion should be maintained. So otherwise it leads to be some defect, that is called lack of fusion. So to avoid this lack of fusion, the two important thing is you should maintain proper heat input and uniform motion of the electrode, welding electrode. So that is why some skilled operators also, one of the factor, if the skilled operator is not there, definitely it is very difficult to keep the electrode, and even the proper angle also should not keep, which leads to be lot of fusion occur into that workpiece also. And coming to the another second important thing is cracking. So in this cracking also, as per this Ishikawa and cause and effect diagram, the main cracking will be occur majorly due to rapid thermal shrinkage. So when you heat it, if you give cool, means again it may be a solid form. Okay, and you should maintain proper heating temperature. The temperature should be kept to proper. If the more heat also will occur, it will come like a liquid form. If you give cool immediately, if you wait certain time, definitely it is there is a changes in shrinkage. And also we should maintain the exact shrinkage, rapid thermal shrinkage. Because of that only lot of cracking will be occur. So this can be avoided by controlling cooling and heating of the weld. You should maintain proper heating and cooling of the electrode and electrode torch. These are the very important thing to avoid such type of cracks. Even some line cracks, hair cracks occur. Even it is very difficult to see. So when you put it in a microscope, that defect, some quality products, when the people are asking high quality without cracks also when we occur, we should be able to maintain the proper cooling and heating of the welder, so which will affect the cracking may be done. And similarly, this excess penetration, this also comes under one of the major welder defect. Mainly this penetration occur due to excessive heat input or too slow motion of the welding. So even more heat and slow. This is what whatever thing you should have the balance, either speed or whatever the heat input, giving the input and movement of that electrode. These should be maintained effectively. So otherwise there is a penetration, some crack and some joint may be uneven shape will be occur. Penetration, some excess metal come out and come down will be occur in this type of things. That's why you need to maintain the balance between the operator speed and welding heat also. But operator speed is very less. If you put more welding, means some more penetration occur. So that is why in order to have some proper penetration, so definitely you need to maintain the balance between the operator and heat input. Okay, and coming to the porosity, so even in the casting process also porous in nature. So even that the sand preparation is properly made, definitely you will have some porous in nature. But here, due to some air trapped in these solidified weld metals, especially the welding performed in open, natural, even some air particles, some dust particles. That is why while performing the welding, some cabin type we should use. So if you are not using proper cabin type, obviously some porous in nature, some air trapped, some bubbles will be occur in that weld metal. Okay, so that is why in order to good in nature, definitely you should be able to maintain the some box and good cabin to be performed this welding process for disturbing, without disturbing of the air and dust particles and all. And another important thing is inclusions. So inclusion also one of the major welding defect, either it may be a MIG welding or TIG welding, etc. This occurs due to inclusion of slag from various sources. Slag in the sense some flux. So even suppose the electrode rod having more fluxes and all, due to that more cooling, more heating, it is like in a fluid form will occur. That fluid will fed into the workpiece. It leads to be some inclusion. some shape of inclusion may be introduced in that workpiece. That is why you should able to maintain the exact, that the filler should be also properly, you should able to made. Even filler of lot of excess is there due to heat. That filler will have some fluid level, so that it will fell on that workpiece also. So these are the some of the basic welding defects. The first one thing is lack of fusion, cracking, excess penetration, porosity, inclusion. So each defect there is a solution also. That is why for the lack of fusion you need to maintain the proper heat input and uniform motion. While cracking occurs, you need to have heating and cooling should be maintained in a proper of their required materials also. Ferrous material, how much heat should be maintained, how much cooling should be maintained, and even the penetration also. There is a balance, work balance between the operator speed and that electrodes. Okay, and porous in nature. That is what some place should also very important. You should close to a box, some square shape can be used so that to eliminate some dust particles, air particles, in order to avoid the air trapping. And finally, inclusions in the sense, wherever the some inclusions in that electrodes and all, so there you should able to prepare the proper ISO certified electrode should be used so that the inclusions cannot be occurred in the performing the welding process also. So this is what about general type of welding and how the welding can be defined, and we have discussed some of the basic arc welding process and SM shield metal arc welding, and another thing is tungsten inert gas welding and metal inert gas welding. So these are the some important type of welding process. In the next session I would like to give some more welding process and its principle and its advantages and application of the welding process. Thank you for this session. Good luck.
Like, share and subscribe. Hit the bell icon for more updates.